Welcome to Ask and Learn.
This question is asking about how bohrium, a transuranic element, can in fact be synthesized from the fusion of two different elements, berkelium, which is itself also a transuranic element, and neon. Now, in this case, the berkelium has a mass of 249 and an atomic number of 97. The neon, as often does, has a mass of 22 and a proton count of 10. So, once figuring out that the resulting mass of the bohrium is 267, and adding up this mass up here, we find that we are missing 4, because 249 and 22 make 271, which will not account for all of the mass seen in the bohrium, which means the leftover amounts must consequently be neutrons. And in fact, there are 4 of them. And this will address Part A. Now, Part B states that if we have 199 atoms of bohrium-267 that could be made, how much time would elapse if only 11 atoms of it remain after 15 seconds? That is, 15-second half-life. So to answer this, we will use a half-life equation, specifically one that looks for time. And the equation is as follows. The natural log of the amount remaining at the time, that is, we don't know yet, which is why we're looking for it, compared to the original amount present, divided by the negative natural log of 2 over the half-life given. In this case, we will plug in what we have. We don't know time, we're looking for it. We know by the time it is reached, there will only be 11 atoms left, compared to 199 at the start of this decay. The negative ln of 2 simplifies to negative 0.693, and we know that the half-life is 15 seconds. So at this point, it is simply a method of plugging this into our calculator. Once this is done, we will find that the time will end up being 62.7 seconds. And this leaves us with the final question, which is, what is the expected electron configuration of this element that was synthesized? To do this, it'd be best to look at a periodic table. If you look and find bohrium on the periodic table, you'll notice that it's element number 107, and it is in fact in the 7th period. The 6th period terminates at the very end with radon. So we know for a fact, unless we want to write out so many elements and electrons along the way, we'll begin by using shorthand with the last noble gas that appears before bohrium, which in this case is radon. On the 7th period, we begin with the s orbital block, which is francium and radium. So that will put us with 7s2. After that comes the actinide series, which in most periodic tables is jumbled down at the bottom so as in order to accommodate space. But this will take on thorium all the way up through lawrencium, because it's normally found between actinium and rutherfordium. Now, this is a count of 14 elements in between, and the lanthanides and actinides represent the f orbitals, another benefit to having it separated out on the bottom. So, these, in fact, will be 5f, and the way we know this is, if the s orbitals begin on the first energy level, and the p orbitals begin on the second, and the d orbitals begin on the third, then the f orbitals must begin on the fourth. But the lanthanides are the first F strip on the periodic table, so the actinides are in fact the fifth. And there are 14 elements, as we mentioned before, from thorium to lawrencium. And then that will leave us, lastly, with the following elements: actinium, rutherfordium, dubnium, seaborgium, and finally bohrium, which we are analyzing. And between all of these, there are what appear to be 5 elements. And based on that, and the fact that the d orbitals start on the third energy level, and this is the fourth d level, then this must make it 6d5. And we can verify this. I'm going to go ahead and box the answer here. We can verify this by counting up the number of electrons present, assuming that bohrium has not ionized, which the problem does not give us any indication that it has. And if we add everything up, it should add up to the atomic number of bohrium, which again is 107. So we have 19 plus 2 plus radon's atomic number, assuming that all of them are full, which will indeed add up to be 107, thus confirming that this is a reasonable answer.